Okay, that's what the theorem actually says for this specific problem. Looking at the next one, we're going to look at IVT algebraically again, and in this one we're going to look at, is it closed? From 2 to 5, yes, unless there is a domain issue. This is a rational function, so we know that there is a discontinuity at x equal to 1. What type of discontinuity? We'd actually have to go through and factor it, and it looks like the top factors to x plus 2, x minus 1, on the bottom x minus 1, so the discontinuity is a removable at x equal to 1. So some of you might think that we get to stop here, but if you look, 1 is not in the interval from 2 to 5. So we actually have a closed and continuous function from 2 to 5. So we can actually keep going. So IVT holds because it's closed and continuous on 2 to 5. So now we're going to look at figuring out what C value. We'll get this to hold, so I'm going to do this right in the center. A C value of 6 is equal to x squared plus x minus 2 over x minus 1. And actually, you can really use a simplified version of this because we know that the only difference between f of x and the simplified version, which is x plus 2, is the point at x equal to 1. So I can actually do this. Now, I'm going to go through and find this, and I realized, so the C value I'm looking at is 4. 4 is within the range. What I realized is I forgot to find the range of values. So we're going to look back over here, and I'm going to do in purple f of 2 and f of 5, because we want to guarantee that 6 is within the range of values that I'm allowed to use. And I'm going to use the simplified version of the function, which is right here. And so 2 plus 2 is 4, 5 plus 2 is 7, so the range of values are from 4 to 7. The value of, or the y value of 6 is within 4 to 7. That's how I know that I was guaranteed an x value, or a C value, where the y value is 6. And I actually found that value right here. So I did this one a little bit out of order, which I probably shouldn't do, but I've recorded for so long now that I don't want to stop and start over. Let's see. And the last one I have here is numerically. So IVT numerically, we're really looking at a table. It says, given that f of x is a continuous function from 1 to 10. So I know that it's continuous because I said so. I can tell it's closed because it said so. So I know just by those two things that IVT holds. Let me use black here. Maybe brown, like red. Okay, what is the minimum number of zeros that f of x must have? And the reason why we say minimum is IVT only guarantees a minimum of 1. So we could actually have more and more. So we want to see what range of values will 0 fall into. So from -3 to 1, I can tell that we will hit a y value of 0, going from a y value of -3 to 1. So there's 1, 0, and it's within the domain of 1 to 2. From 1 to 5, I will not be guaranteed 1, but it could happen. The function could really drop down from a y value of 1, go negative, and bounce back up to a y value of 5. And that would mean that we have a 0, but we can't be sure that that's what the graph is going to do. So then we go from 5 to 8, definitely not guaranteed another one, but 8 to -2, we are guaranteed another 0 because the y value of 0 is within 8 to -2. So I'm going to put an and. The domain of 9 to 10, we're guaranteed another 0. Okay, so the answers I'm giving are x values. We were looking at the y values to figure out at what x values a 0 would occur. Okay, letter B, what is the minimum number of times that f of c equals 4? Y, and within what smallest intervals? So essentially similar question. So this time we're looking at a y value of 4. So am I guaranteed a y value of 4 from -3 to 1? No, I am not, because 4 would be outside of that range. But from 1 to 5, definitely guaranteed a y value of 4, because 4 would be within 1 to 5. 5 to 8, I cannot be guaranteed, but 8 to negative 2 again, I am guaranteed a y value of 4 because it's within that range. So for the last one here, you would be within 2 to 6 and, oopsie, not 8. Where is the back button? 9 to 10. How many are we guaranteed? A minimum of 2 points. And here we're a minimum of 2 zeros. So in summary, we need the function to be closed, continuous, on the interval from a to b. What happens outside does not matter. Then, given the continuous interval from a to b, every y value from f of a to f of b is guaranteed in the domain of a to b. And that's actually what creates that box. The width of the box is a to b. The height of the box is from f of a to f of b. Now this can also be written as f of b to f of a, depending on which value is bigger. So if it's an increasing function, then f of a to f of b would be the correct way to write the interval. But if it's decreasing, we would have f of b to f of a. And when I say decreasing, I mean from the y value to the next y value.